Hello friends, I am Shivaji Sonore. Welcome to the class of physics. In this video, I will explain the concept of transistor, biasing of the transistor, configuration of the transistor, and applications of the transistor. In the first part, construction, working, and types of the transistor. Second one, characteristics of this transistor in CE configuration. In the third case, we'll see the transistor as an amplifier as well as transistor as a switch. And at the end, the concept of gain. The first part, that is the construction of transistor. What is meant by transistor? Actually, transistor is the sandwich of two p-n junction. When two p-n junctions get joined together, there is a formation of transistor, and there are two types of the transistor. One is known as NPN transistor and second one is known as PNP transistor. This transistor consists of three regions. First one is the emitter, second one is the base, and third one is the collector. Emitter is large in size and heavily doped. Base is small in size and lightly doped. And third one is the collector. It is large in size and lightly doped. This is the symbol of this NPN transistor, and in this NPN transistor, this arrow is in outward direction. This is the emitter terminal, base terminal, and collector terminal. Emitter, this arrow indicates the direction of current along the emitter terminal, collector, base, and the emitter. This is the symbol for NPN transistor. Second one, that is the PNP transistor. In this PNP transistor, one change is there, that is the arrow of this is towards the base region, and this arrow indicates the direction of current. So in NPN and in PNP, the direction of current is exactly in opposite direction. In NPN from collector to emitter, and in PNP from emitter to collector. This is the simple construction of the transistor. Symbol, that means it consists of three terminal, emitter, base, and collector. So we'll see the actually construction of this transistor, and after this there is a biasing of transistor. This transistor consists of different is get manufactured by using two p-n junction. For the motion of this majority carriers, it require external source, and depending upon the polarity of this external source, there are different types of forward bias, and second junction also in forward bias. This is known as forward biasing. Second one is forward reverse biasing. Third one is reverse biasing, and fourth one is reverse forward biasing. Transistor is always connected in forward and reverse biasing for its application for the working. So this is the NPN transistor. We'll see the action or working of this transistor. So this is the NPN transistor, emitter region, base region, and collector region. First, biasing voltage, that is voltage across emitter base, that is VEB, and voltage across base and collector, this is collector base, that is VCB. So these two biasing voltage is applied across these two PN junction. Then what happens? This first emitter diode is in forward bias and second diode is in reverse bias. So when this voltage is get applied, the electrons which are present in the N regions get emitted to the base regions, and small amount of 5% of electron is get recombined with the holes in the base regions, and remaining amount of 95% of electron transferred to the collector regions. Means there is a motion of electron from emitter to base and base to collector, and the direction of current is from collector to emitter. Due to this motion of electron, current is flowing to this each region, and this current is IE, IB, and IC. According to the working, the direction of current or the total current through the circuit is, it is IE is equal to IB. Be careful, only small amount of electrons recombine in the base region, that is the 5%. So current through the base terminal is very small, and current through the collector terminal is maximum, and the total current through the transistor is emitter current IE is equal to IB plus IC, means current through the emitter terminal is equal to the algebraic sum of current through the base terminal and the collector terminal. So this is the action of NPN transistor. Similarly, the second part, that is the action of PNP transistor. This PNP transistor consists of majority carriers, holes as a majority carriers. So P region, then N region, and the P region, emitter terminal, base terminal, and the collector terminal. Two biasing voltages. When you see carefully, see here, these holes are moved due to the biasing voltage and get diffused across the junction. So this deflection width for emitter base is very small and deflection width for base and collector is large. So it is in forward and reverse biasing. So again, holes get transferred from emitter to base. Small amount of holes get recombined with the electrons in the N region, that is the base regions. Remaining amount of holes are transferred into the collector region, so it is known as collector. So the direction of motion of holes is from emitter to base and base to collector. And the direction of current is also from emitter to base and base to collector. It is in the same direction of motion of holes. So this is the emitter current, base current, and the collector current. So some biasing voltage VEB, VCB is applied across this junction. Again, small amount of holes recombine with the electron in the base region, and due to this, again, the relation of current I is equal to IB plus IC is remains same for PNP transistor also. So in both type of transistor, the relation of current, emitter current is equal to IB plus IC is remains same. Next one, we'll see the configuration. This transistor consists of 3 terminals, but for the input, it requires 2 inputs, and at the output, it requires 2 inputs, 2 terminals. So out of these 3 terminals, any one terminal is common, and depending upon the common terminal, there are 3 types of the configuration. One is common emitter configuration, means emitter terminal is common to the input as well as to the output. Similarly, common base configuration and common collector configuration. So we'll see the IV characteristics of transistor in common emitter configuration. This is the circuit diagram. This is PNP transistor. Then this is the biasing voltage applied across base and emitter region, and it is in forward biasing. Second one, this is the another one biasing voltage, that is VCE voltage applied across collector and emitter. This is the rheostat to change the voltage. So by using this rheostat, we can change the applied voltage, and with respect to change in input voltage as well as output voltage, what is the current through the base terminal and through the collector terminal. So this is known as input characteristics and this is known as output characteristics. So in the input characteristics, we'll see in the input characteristics, this VCE is remains constant. That is the voltage across collector and emitter is remains constant. Then change the voltage across VBE, that is base emitter, and measure IB. Then the IB characteristics is known as input characteristics. This input IB characteristics is same as the IB characteristics of diode, PN junction diode in forward biasing. And with respect to increasing VCE, this is actually VCE, the current is slightly, this IB current is slightly get increases. So this is input characteristics. Be careful, IB is always in microampere, and this is the input voltage. Similarly, we'll see the output characteristics. In the output characteristics, this base current is remains constant, like as 100, 200, and 300, and then change this VCE and measure the collector current. So IB is remains constant, change VC and measure IC. So when you see carefully in the output characteristics, it get divided into the 3 regions. One is known as cutoff region, means when both this diode, emitter diode and collector diode are reverse bias, current is equal to 0, known as cutoff region. In the second case, when both the junction, both the diodes are in forward biasing, this is in saturation region. And then when this transistor is in forward and reverse biasing, this collector current slightly remains constant, and this is known as active region. So this is the IV characteristics of transistor in CE configuration. Then we'll see some applications of transistor, that is transistor as an amplifier. To understand this transistor as an amplifier, this is NPN transistor in common emitter configuration. The biasing voltage VB and biasing voltage ECE. Then input voltage is applied. This is the input voltage. Input voltage is applied to the base and emitter junction. This is the small signals, and this positive half cycle is applied to this two terminal. Then what happens? This input signal changes the base current, or it forward bias the base and emitter junction, and due to this base current is get changes, and at the same time due to this collector current is get changes, and then or the collector current get increases, then the voltage drop across the load resistance get increases. So the output voltage at the load resistance get increases, means you can say that the input signal is get amplified at the output, but there is a phase change of 180 degree because this transistor is used in inverting mode. Similarly, when this negative half cycle is get applied, then the base current changes, collector current get changes, and the voltage drop across the load resistance get changes, and the voltage drop across the load resistance get increases, and it is maximum. So this is the transistor as an amplifier in common emitter configuration. We know that according to the action of transistor, emitter current is equal to IB plus IC. So what is the load resistance? So according to the Kirchhoff's law, voltage across collector emitter junction VC is equal to V, this is ECE minus IC RL. So this is the transistor as an amplifier circuit. Next one, actually this is the some part of this transistor as an amplifier. According to this equation, what is the working when the positive half cycle is get applied, the voltage drop across the load resistance get increases, and the output signal is negative for the positive input signal. Similarly, when the negative half cycle is get applied, then the output signal is positive. So finally, we conclude that input and output are the out of phase by 180 degree. Then next one, the concept, that is the gain. Gain means it is output, it is the ratio of output current to the input current. So in common emitter configuration, output current is collector current and input current is base current. So ratio of collector current to the base current is known as current gain. So for C configuration, it is known as beta. AC current gain. What is AC current gain? This is DC and this is AC. AC means change in collector current to the change in base current. AC voltage gain. Voltage gain means the output voltage to the input voltage. Voltage across this VCE, which is get changed with respect to change in input signal. This ratio is known as voltage gain. Then the power gain. Power gain means again change in output power to the input power. So this is the concept of gain. Then we'll see the relation between two current gain factor, that is alpha and beta. Alpha means it is the ratio of IC upon IE, that is for common base configuration, and beta means it is IC upon IB. Alpha is IC upon IE and beta means IC upon IB. This is the two current gain factor. According to the action of transistor, I is equal to IB plus IC. So divide this whole equation by IC. We get to the left side I upon IC, IB upon IC plus 1. IC get cancelled. Take the reciprocal of this. So we get 1 upon alpha is equal to 1 by beta plus alpha plus 1. So we get two equation in terms of beta and in terms of alpha. Beta is equal to alpha upon 1 minus alpha and alpha is equal to beta upon 1 plus beta. Be careful. The value of beta is multiple of 100. Maybe it is 500, 400, but it is multiple of 100. It is due to the ratio of IC upon IB, because IB is in microampere, so 10 raised to minus 6 to the denominator. In the numerator, there is a 10 raised to plus 6. Similarly, alpha is the ratio of IC upon IE, means both are in milliampere. So value of alpha is less than 1, it is nearly equal to 0.99. So this is the standard value of this alpha and beta. Another one application of transistor known as transistor as a switch. In the transistor as a switch, again this NPN transistor is get connected in forward and reverse biasing, and this is the input voltage and this is the output voltage. So there are two possibility, two cases when input voltage is equal to 0. Input voltage is equal to 0. This base and emitter junction is not forward bias. So this base current, emitter current is equal to 0, means this transistor is in off state. Current is not flowing through the transistor. So we can say that this is in the off state. Second one, when some input voltage is applied, then base and emitter junction is in forward bias and the current is flowing through the emitter. So current is flowing through the transistor and it is known as the transistor is in on state. So in this way, this transistor is act as a switch, means when current is not flowing through the transistor, off state. When current is flowing through the transistor, it is on state. So this is transistor as a switch. According to the Kirchhoff current law and voltage law, we can write down the equation of current as well as equation of voltage. So this is the second important semiconductor device known as transistor. So this transistor is used as an amplifier as well as switch. So this is the part of transistor. In this video, we'll see the construction, working, type of transistor, then biasing of the transistor, configuration of the transistor, IV characteristics of the transistor, current gain factor, as well as transistor as an amplifier and a switch. Thank you.